Okay, so we know oxidation is loss and the charge goes up. Reduction is gain and the charge goes down. And these are things that I like to write on the top of my redox test. But then you're like, well, okay, well, what is the charge then? So to figure out if the charge went up or the charge went down, you need to assign charges. And you might remember doing this from bonding unit, I guess. But here's an example where charges have been assigned, and now you can use them to figure out whether something was oxidized or reduced. I'm going to tell you that, and then I'm going to show you how to assign. I'm going to remind you how to assign these oxidation numbers. So you could go, okay, Na, you were 0. Now you're +1. Looks like the charge went up. Okay, so that got oxidized. Cl, you were 0, now you're -1. Your charge went down, so that's reduction. Okay, Cl is the thing that got reduced. Okay, so you're going to need to know how to assign these little charges because they're not always going to be there for you, so that you can do this. So those little charges are called oxidation numbers. So we would say, what are oxidation numbers again? Okay, so what they are is they are in the top right corner of the little box on the periodic table, and it's kind of telling you like what charge that thing likes to become once it's bonded. So it's like, okay, Na has 1 valence electron. It really likes to lose it and become +1. Cl likes to become -1 because it has 7 valence electrons. I was supposed to say -1. So it likes to gain 1 to get 8 valence electrons. So it's kind of like instead, okay, Na has 1 valence electron. I'd rather lose it. That's +1. And figure all that out. It just tells you Na likes to become +1. So it kind of just like saves you a step. You could also figure it out in your head based on what group they're in. And again, Cl, instead of being like, okay, it's in group 17, so it has 7 valence electrons, so it likes to gain 1. And when it gains 1, it becomes -1. It just tells you right here, here's what Cl likes to do. It likes to become -1. Okay, so that's what an oxidation number is. That's where you find it. Now I'm going to teach you how to assign it in like a whole equation like this, so you can then figure out, did it get oxidized up or reduced down? Okay, so how do you assign oxidation numbers? So like I said, they are the number in the top right corner. But another thing to remember is, and we did this in bonding, let's see, you had Fe3O2. Sometimes there's multiple possible choices. Like if you look at Fe, it says like +3 or +2. So what do? Okay, well, you skip Fe and you go to O. O only has one negative choice. I actually wrote this wrong. This should say Fe2O3. So you're like, okay, O is -2. So what does Fe have to be? And I have to say, well, wait a minute. O is -2, but there's 3 of them, so that works out to -6. So I really need Fe to be +6. But wait, there's 2 of them. Sorry, I made that little typo before. So 2 things have to add up to +6. So I guess each Fe must be +3 because 2 + 3 would equal +6. So then I have a +6 and a -6. That adds up to 0. Now I know I did it right. All right. So oxidation numbers, again, it's the charge that it can be positive, negative, and we will learn about when it can be 0. And if you remember, if you look right here, see how I was doing like the actual oxidation number on top and the math, like the +6, -6 down here. That is how I'd like you to do it, because when they ask for what's the oxidation number, this up here is your answer. These down here are just the math that got you there, and you don't want to act them as the answer. Sometimes it's the same, but sometimes it's not. All right, so you just go through, just like I did, and you go, okay, Fe, I don't know what you are, so I'm going to skip you. Okay, oxygen's -2. There's 3 of them. That makes -6. So this has to be +6. So, but there's 2 of them, so it must be 2, 3 pluses. All right, so that's a hard one. Next one, I have a C and an O. If I look at C, it's got a lot of choices. So I go to O. O is -2. So I'm like, oh, C must be +2. Done. The math down here works out the same because there's not like 3 of them or anything. Over here, I get to Fe, and I start looking up, okay, Fe, is it +2 or +3? And then I go, oh, Fe, actually it's alone. It hasn't bonded. It hasn't given away electrons, hasn't taken electrons. So when something is alone and it hasn't bonded yet, it actually has a charge of 0. And people always forget that, and I forget it. I'm like, I see Fe and I'm like, wait a minute, it's not with anything, it's a 0. So the way I remember that is that when you are alone, you're a 0. Isn't that sad? Even if you are hanging out with yourself, like 2 Fe's, like Fe and Fe, you're still a 0. All right, then moving on to CO. Again, I don't know what C is, but I know O, if I look it up, is -2. So then I'm like, oh, C must be +2, +2 minus 2. My goal is that each little compound, this adds up to 0, this thing adds up to 0, this thing adds up to 0 because it is 0, and this adds up to 0. So I have a few more rules. That's all stuff you've already learned except for the 0 thing. So I'm just going to share a few rules with you. Okay, so we just learned this one. An element that's by itself is a 0. And again, that's because it hasn't lost electrons, hasn't gained electrons, hasn't bonded with anyone. So it's just a regular atom, and it is a 0. If something already has a charge, that is its charge. Like if it says Cl -1, its charge is -1. If it already says Al3+, that is its charge. So sometimes they will just give you the charge, and that's what it is. You're done. It's a nice little shortcut. Group 1 metals always, if you look down group 1, they all say +1, +1, +1. If you look down group 2, this should say +2, not -2. They all say +2, +2, +2. But you can just look that up. Fluorine is like the most electronegative. It's always stealing, so it's always negative. Hydrogen is pretty much always +1. It can rarely be -1. The only reason it would be with -1 is if it's with something that can only be plus. So if it's with like a group 1 metal, group 1 metals, the only choice is +1. If you look at hydrogen, it has a choice of +1 or -1. So if this comes up, if you bond these two together, then H is like, all right, if you can only be +1 Na, then I'll be -1 this time. But other than that, you're going to use H as +1 so much that you'll have it memorized. Oxygen being -2, you'll use it so much you'll have it memorized. There is an exception, but I don't think people even learn that during the school year, let alone from home. Okay, and the last one is we're always trying to get things to add up to 0, but if something like this, like a polyatomic ion, already has a charge assigned, that is telling you that PO4, whatever's in there, adds up to -3. So it's, in this case, it is not going to equal 0. It's going to equal what it says it's going to equal. So here, instead of trying to get everything to equal 0, now I'm trying to get it all at -3. So to show you what I mean, let me do it. So if I look up P, it's got multiple possible charges, so I'm going to skip it. O, you are -2, and there's 4 of you, so that adds up to -8. So again, notice I'm doing my math down here and the charge up top. So then normally I'd be like, oh, well, this must be +8 to make the whole thing equal 0. But no, we're trying to equal -3. So I'm like, what number would P have to be so that -8, what -8 would equal -3? A +5. So then I'm like, oh, P is +5. All right, so that's our last rule, is that if something has a charge, then it does not add up to 0. It adds up to that charge. Okay, so the last thing to do is just to practice. And again, the reason we're doing this is so that once the numbers are assigned, you can see, did something get oxidized up in charge or reduced down in charge. So I'm going to go to this first one, HSO3. H's are almost always +1. There are 2 of them, so that makes +2. So I do the actual charge up top and the math down bottom. S, when I look, it has multiple choices, so I'm going to skip it and come back. And then O is -2. I have that one memorized. And does that say 3? I think it says 3. So there's 3 of them, so 3 -2s makes -6. Okay, so now I have +2 plus question mark, whatever S is, -6 adds up to 0. So what must S be? If 2 plus whatever S is -6 equals 0. So it's kind of like I'm trying to get the pluses to equal a negative. So -6, then I'm going to want S to be +4. So that I have 2 plus 4 is +6, -6 equals 0. So now I'm like, okay, S must be +4. All right, so I've assigned the oxidation number for each one. And the one that they'll usually ask about is usually that middle one that's kind of like annoying to figure out. They won't usually ask the easy one, unfortunately. Okay, on to the next one. Fe, don't know its charge, so I'm going to skip it and come back. Cl has a lot of choices, but only has one negative choice, and that's -1. So I'm going to choose that. And then there are 3 of them. So instead of saying, oh, well, Fe must be +1 if it's -1, well, no, because there's 3 Cls. Okay, so 3 Cls, that's -3. So Fe must be +3. And just note about this, we are going to do so much in this unit. It's all going to be based on assigning these little numbers. So you really want to get good at assigning these little numbers. Okay, so I figured it out. Fe is +3, Cl is -3, because that +3 -3 adds up to 0. So this is just the math down here, the +3 -3. These are the answers for the oxidation numbers. Fe's oxidation number is +3. Cl's oxidation number is -1. It just happens to be that there's 3 of them that adds up to -3. So this was my math that helped me figure it out. These are my actual answers up here. All right, next one, PO43 negative. P, when I look it up, has lots of choices. And again, if you forgot, I'm getting these numbers off the periodic table. I'm getting them from the top right corner. When I look at O, top right corner says -2. So I'm like, oh, good old O. I always know you're -2. And then there are 4 of them. So that makes -8. So then I might be like, oh, P must be +8. But no, this little charge right here says that, hey, this thing doesn't add up to 0. This whole thing has its own charge equals -3. So now I'm like, all right, what must P be if whatever P is -8 equals -3? So I'm like, okay, I think it's 5 minus a -8 equals -3. And that is the answer. All right, so these are my answers, oxidation number +5 and -2. This was my math that got me there. Okay, so if you get these, you can stop and you can go do the problems in the homework, but I'm going to keep doing them for anyone who wants to see them. So D, H is pretty much always +1. N, if I look at it, the top right corner of N has like a lot of choices, so I'm going to skip N and come back. O is -2. So I might just at a glance think, oh, H or N must be +1, so this all adds up to 0. But no, there are 3 -2s. So 3 -2s makes a -6. H was +1, and there's only one of them. So now I'm like, what does N have to be so that the whole thing equals 0? So again, usually I want the pluses to equal the minuses. So if I have -6, I kind of want this to add up to +6. So I'm like, oh, this must be +5, because 5 and 1 makes +6, -6 equals 0. So I figured out that N must be +5. Sorry, that's just like an arrow. N must be +5. So H is +1, N is +5, O is -2. So these are my answers. That's my oxidation numbers. These are the math that got me there. Sometimes they're the same, sometimes they're not. All right, on to the next one. First thing I want to take note of is that it has this -2 in the corner. That means it has its own charge. I no longer want to equal 0. I want to equal -2. So I'm going to write that before I forget, because it's easy to forget. So if I look at CR, top right corner, it's got lots of choices, so I'm going to skip it. Good old O is always -2. That is not what that -2 in the corner means. That -2 that I circled is for the whole thing. So O is -2, and there's 7 of them, so that's -14. CR, therefore, I'm thinking, oh, it must be +14, but no, it has to equal -2, so it must be +12. CR must add up to +12, because 12 minus 14 is -2. And then, so I'm like, okay, CR is +12, but wait, there's 2 CRs. So I need 2 CRs to add up to +12. So it must be each of those 2 CRs is actually a +6. All right. So again, these are my answers for oxidation numbers. This is the math that got me there. So this is what I actually want. And I was trying to make everything equal -1. Okay, last one. I don't think you'd see an exception like this. But usually you're like, oh, O is always -1, or -2. But it's first here, which is kind of your clue that it's a weird one. So F only has one choice, that's -1. There are two of them, so that's -2. So it kind of like forces O to be a +2. So that the whole thing adds up to 0. So those are the answers. And that is a weird one, but it can happen. So that's where I want to remind you that those numbers in the top right corner are the most common choices, and we do usually see them. But there can once in a while be something on there like O is supposed to only be -2, but it can also once in a while be +2. But they don't bother putting it on there because it's so uncommon. So there can be numbers that aren't on the box, but I hope you won't see that. So again, just trying to assign these oxidation numbers so that everything adds up to 0, or else the charge that is assigned, so that we can then in our next lesson decide, did the charge go up, did it get oxidized up, or reduced down? And we'll need to look at these charges to figure out what happened.